Hello and welcome to become a full stack developer. So in this tutorial, we are going to cover a decision tree in a practical way. And as we have already learned in our previous video, what actually the decision tree is in the concept wise and the terms we used for the decision tree. In this video today we are going to learn about the decision tree in a practical way. Before starting the programming actually, I have to just discuss something about that, which library we will use and which programming language we are going to use. So here we start with the Python. I have already have some basic tutorial for the Python that help us to learn machine learning in Python. So I have designed that video just for a conceptual wise, not like in a very depth like the full course. That is a just basic knowledge about the Python that help us to understand the Python in a, I mean the machine learning and the Python in the same way. So the thing that we will use for the machine learning, there are different options. To start with the coding, the another first one is the spider. Actually this is a spider for Python. You can say that spider for Python. This is a software that you can download for the uh, for the uh, your development purpose. Or there is another thing that is anaconda. If you just download the anaconda, and there is a different option in the anaconda. You can download a Visual Studio Code, or you can run a Python, you can use a PyCharm, or you can use any other IDE. IDE it's a just your framework or your environment where you want to write the code. And the another thing is relating to the data set. As we know that the whole machine learning works with the data sets, and there is already millions of data set that people have used everywhere, and they have uploaded in some common places where you user can, I mean the people can download and use their own purposes, just for a testing purpose and just for the learning purposes. So the first website that has a very big collection of data set, that is a Kaggle. So if you just search the Kaggle, like a Kaggle, and then you just click on the data set, or you click on this one, so you will land to this website. And here there are different types of data sets. You can search a different, like the all data sets, computer science and all that. But in our video, because we are going to discuss a classification problem with a binary classification, so I have to select a diabetes data set. You can see that here are different types of diabetes. This one. These are the different data sets we're using for the different purposes. And here the another option is, like I said, we can use our own premises for the development. But here today we are going to use a collab is a Google. Here is a collab, that is a Google, I mean the platform in simple wording that give us to write your code and run the things, because there is already lot of libraries are already added, so we don't need to add a common libraries. So when we click on the collab like this, so it comes over here. When you click on the new node, so it comes like this way. And if you guys have not this option, I mean this icon, the uh, Google, this is actually Google Drive option. So when you can rename the file like a file one or whatever files or whatever. or you can the another option is that you can save a copy of this file in a github, so that in while you're working, so your file is updated onto the github as well. Or you can save this copy of your file into a drive. Like when you click on this, so it will open in a Google Drive. So now your file is totally is in a Google Drive. So if you do any change in the file, it will automatically save onto the Google Drive. And the another thing is that if I come over here, here is an option. When we click on here we can upload the images or upload the sample data, whatever. But I have already uploaded that in my uh, file. So I have uploaded a diabetes.csv. And let's start with the actual coding now. Here is the some library that here is the some, actually there is some two new thing that I have to I'm just what I have to discuss this, the code and text. When we click on the text, so it start with the something like this. And when you come to here, so it shows like a text at the top and then the code. Why we use that? Because sometimes we are working and we want to commenting the code, so like the for the other people, they can understand that what actually it is written and what is not. And what I have, okay, so here is a one library. We are using the pandas is a library we used for the we use for the multi-dimension array. And this is open source library. If you guys just want to search over here, might be the pandas, so we can get at least a basic idea about the pandas is open source library using for the multi-dimension array. And the another you don't have any contacts sharing their and the another option is a sklearn. This is actually the library that is also the open source, and it has a lot of uh, RAD algorithm implemented in this library. So we use that. And I think that's it. And then let's come to the actual point now. I have imported the library pandas and the sklearn the tree, because we are going to use the decision tree. So I have added a tree, but it will have a different option if you just come over here and just try to type. So it will show different options, these cluster classification dummy, all that. Because we are working with a tree, so I just added a tree. Then import your model. This is a model that we will use. And here is another option, sklearn.model section. So which section we will use for the train and test separate. So as we know, the train in the machine learning, there is a concept for the data set. So we train our model in a with the data set, right? So suppose sometime we have only one data set that has almost thousand of record, and we want the same data set to work with the way how we do that. Like if we use the same data set just for train the model, and which data we will have for the testing. If we use the same model, I mean the same data set for the testing, because our model already know the whole data, so that's why we can't use that, and we are not sure that our model will work in this way or not. So we use a train split. We all do I mean, if we have 1,000 record and we want to split the data, might be we want to use a 70% for the training and 30% for the testing. So we use this for that. And here is another thing, sklearn matrix. So this is also for the calculate the accuracy. And here that I have added a column. This is our actual step for the data set. I have made a name for the column name. And if you guys open this diabetes data set, I'm just clicking on this. Now you can see that it has a these record, and has a total record is 768. And the header are, these are the header: pregnancy, glucose, skin thickness, insulin, BMI, all that. So that's why I have added a column name. So we can add any column name. If suppose your data set has a different column but you want to use a column name in your way, so you can add a column name as per you want. And then in the PD, the pandas, as it work with the multi-dimension, because our data set has a head, x and y, I mean the row and the column. So that's why we use a pandas dot read. So the path of your data source, I mean the data set. Here is the data set, because this is a local data set that I have used over here. So if you have a data set in your GitHub or in your any external network, so you have to path that path over here. And then the header, we are showing that we don't need any kind of header. And then the names, so what should be the data set name? So we have added up this name, so it will display like this. And here is the, this is actually name PIMA. This is a reference variable. In a programming language we use a reference variable, or it is just object of, or consider it object of this panda library, the read. So it depends on what actually you want to use it is a data frame in simple wording, which has the whole information of your data set. And here we are using the PIMA dot head, so it will display the he- let me actually comment on this one. When I click on this, our dataset is loaded, but we don't have any information what actually our dataset has. So if I just comment out this, I mean uncomment, and when I click on this, we can check that we can see the dataset information here, right? And the another thing is that because our, this the first row is a our header, so we don't want to use in a in the model. If I do not remove this first row, so our model will create a problem, because the whole data, like these data, is a numerical data, but the header has a string value. So that's why we have to remove that. So I'm just comment over this. Now we can see that PMI, this is our data frame, and we want all data but not the first index. So it, the PMI now will start from this, from here. So this is the allocation. I allocation actually to get the data from a array, and come back to your uh, data frame. So we are removing from the first point to the remaining stuff. So when I click on this, now that's removed. And here we have the next concept is a feature selection. The feature selection is nothing, it's just suppose your data set have might be thousand of columns, or might be hundred of columns, and you are not interested in all the column, but you want to use a few column just for your for your training and for your testing or for your accuracy. So here we make it a feature selection. So we are using these five column, but in over here we have a more than these column. We have these, but we have removed. We are not using this one. We are not using a insulin. I think we are using insulin, but we don't. We have removed some column actually, not all, but we have removed at least one column. So this is a feature selection, and here we have used x mean your feature, and the y mean what actually you are going to predict. So our prediction is a PMI dot label. This is our label. If you want to use a, suppose a target, if you want to make it a target, so here would be your target. So you have to write a target, right, like this. Or but I'm just making it as it a label, and uh, here the same label. So here what actually we have done, we have split, I mean we have feature selected the data set. When I click over here, our value is set. Now here the splitting. So as I said, we have only one data set. Sometime people use a two data set, one for the training and another for the testing, but at the moment we have only one data set, so we are going to split the data set in the 70 to 30%. So we are using a 70% as a training and 30% for the testing. So the train underscore test underscore split that we have imported over here, model selection. So this take a two value, actually many parameter, but at the moment we are passing a three or four. The first one in X, your feature column, and then your target, what actually you want to achieve, and your test split and the test size, what should you want to use for the testing, and the random state, it will randomize your data set. It's including the shuffling. And here is the the output of, I mean, this return of these thing, this return uh, multiple value from this method, and it return x train, x test, y train, y test. I'm just clicking on this, so we have all the value over here. Now this is our model that predict the thing. As we said, we are using a decision tree classifier. So I have make it a clf as a alice name, and then clf dot fit it take the x train and y train, because we are using a train our model first, and then it will predict the response from the test dataset. This is from the train, and then it is from the predict. So first we have fit the model, I mean fit the x train and y train, and then we come to the sorry, x train and y train. Then over here we are going to predict the actual value. So when I clicking on this, so model is fitted, and here is we it has responded something, but we don't have anything to show that what accuracy our model is showing. So we are using a matrix dot accuracy, that is a x test and y prediction. When I click on this, so our model is showing this prediction 0.67 accuracy. I mean 0. Uh, consider 7 is 67%. And one interesting thing is that in the machine learning, no model is returning 100% accuracy. It almost give you a 70%, 80%, 90%. It depends on your how you train your model, how you tune your model. And then here we want to use the some to show up the entry, like how it will look. So we are using a graphics. So this is just display purposes, and then the pi dot play. The graphics is actually it convert the data frame into dots, and the pi dot plus it convert the graphics into a actual image, your png images. And then another thing is this, the display and the io string. And here what we are doing, dot string and string io, then export all that. And then this is just for getting the value, and then we are writing the value into a diabetes png, so like we have over here. So it will save in this way, and then we are displaying that image. So I'm just clicking on this. Now we can see that it take a bit longer. So our decision tree looks like this, but this is not informative at the moment, because this is have a lot of branches and lot of nodes. So how we can do that to make it a more accurate, to make it a more readable, to make it a more optimized, and more, to in a performance wise. So for that there is a one concept, we use a uh, pruning, that we had discussed in our previous video, and while discussing the decision tree. So we are using the pruning as a three depth, and we are using a the same, this is same model, and we are using a creation is a entropy, like we have read in our previous value. And again the same thing, the fit, then prediction, and then the accuracy. When I click on this, now you can see that after making it pruning, our accuracy is increased almost 10%. It is showing a 77%. And again, if I want to display the image, the same code that I have used in the above over here, and the same code, when I'm going to click on this, now you can see that our table will, our so decision tree will looks like this. So this is that how the decision tree is working in the real world. And the interesting thing is that in the previous video we have learned that how to calculate the entropy, and how to get the information in, and how value would be the our root node, and which would be the child node, all that. But you can see that here we do not calculate anything like we have learned in the previous video. So this is just all the thing that your model is automatically doing for that. So I think so that's it for today, and in next video we will cover to the next algorithm in the same process. First we will learn the basic, and then we come to the programmatically way. Thank you for watching.